Since its discovery, has the enigma surrounding Oumuamua been completely resolved? 7 years ago, the interstellar visitor was overshadowed by the main question: what on earth is it? The enigmatic flying object is sometimes mistaken for a comet and other times for an asteroid, and it also confounds experts with its amazing acceleration after passing the Sun. Because of this unexplained acceleration, some even speculate that Oumuamua is actually an alien spacecraft, and it's not us, but renowned Harvard professor AIL. However, astronomers now think they have discovered the true cause of the unexpected acceleration, and it has little to do with exotic research probes or extraterrestrial civilizations. On October 19, 2017, Robert W. Kay achieved a major milestone in contemporary space travel when he discovered an object in the solar system that was obviously interstellar in origin. Despite this, the initial excitement soon gave way to a great deal of misunderstanding. No researcher understood what we were working with because of the object's peculiar and odd characteristics, christened Oumuamua, meaning scout or leader. Experts initially believed the interstellar visitor to be a comet, but this opinion was quickly disproved when all subsequent observations failed to find any comet-like tails or commas. As a result, the astronomical turnaround happened just 1 week after the discovery, and Oumuamua was now regarded as an asteroid. Well, not really, because the object did exhibit flight behavior that defied all known asteroid patterns. However, when Oumuamua was discovered on October 19th, it was already returning to interstellar space. Scientists calculated that it had passed perihelion, the point closest to the Sun, on September 9th, and while it had come as close as 36.6 million kilometers to our mother star during this time, it did something that left the scientists completely perplexed. In detail, the orbit analysis revealed a mysterious acceleration, meaning that when it moved away from the Sun again, it traveled a little faster than the mere influence of gravity would have permitted. From that point on, experts were unavoidably faced with the question of what caused this unexpected speed boost. This assumption had a small but important catch, because typically outgassing is accompanied by a significant change in rotational behavior, which was simply not detectable in the case of Oumuamua. Initially, outgassing of volatile components was suggested as a potential explanation. This is not surprising, as such a process is anything but unusual and occurs among other things when a body is heated to high temperatures. The mystery grows in order to reveal Oumuamua's actual beginnings. Experts then focused almost all of their available telescopes on the interstellar visitor. During this process, they also discovered that the object exhibits unusually strong brightness fluctuations, which suggests that it resembles an enormous cigar in shape. However, the data they had gathered was insufficient to reconcile the brightness fluctuations with a suitable rotational behavior, so it appears that Oumuamua lurches through space rather than rotating around one of its main axes. What's more confusing is that no dust was found in the immediate vicinity of the object, leading scientists to assume that it is made entirely of metal and does not contain water. Due to the lack of concrete data, the experts once more had to rely on estimates. Depending on the values used for reflectivity density, internal tensile strength and axis of rotation, different dimensions result, so it is possible that Oumuamua is 800 or only 100 meters long. Scientists have not yet provided a definitive answer regarding the object's origin. The ambiguous approach only suggests that the direction of origin is somewhere in the constellation Lyra. Oumuamua was reclassified as a comet shortly after it was first classified as an asteroid, but not all researchers agree with this classification. Other studies have found that the object is more likely to be made of frozen hydrogen, or possibly a nitrogen ice fragment that was once blasted out of an exoplanet similar to Pluto. This is conservative so far, but it could be much more contentious. Harvard professor Ayob actually took a somewhat different approach to the Oumuamua riddle, speculating that we could not be dealing with a natural item at all, but rather an intentionally constructed one, the extraterrestrial spaceship known as Oumuamua. Ayob is not exactly what you would call an uncontroversial astrophysicist. For instance, he claimed to have discovered mysterious objects at the bottom of the Pacific Ocean that would indicate, I quote, extraterrestrial technology. More specifically, he claims to have found hundreds of spheres of interstellar origin in the remains of a meteorite. You may also recall the alleged alien mummies that were presented in the Mexican Parliament in September 2023. And guess who was live-streamed from Harvard to report on the search for extraterrestrial objects in the solar system and atmosphere? Elle hypothesized that Oumuamua might be a solar sail, a body driven by the radiation pressure of the Sun or another star, based on the observed acceleration and the absence of dust formation. However, if you believe that the rest of the research, community immediately rejected Elle's comments as complete nonsense. You are mistaken. In fact, the possibility of an artificial origin was at least not ruled out, and a few weeks later, the radio telescope at the Green Bank Observatory in West Virginia turned its gaze to Oumuamua to look for possible signals of artificial origin. However, the alien enthusiasts were met with the sobering news that no evidence of artificial signals could be found. Although Oumuamua was discovered in October 2017, as previously mentioned, it wasn't until March 2023 that the reassuring news finally spread, and astronomers announced that they had finally solved the mystery surrounding our interstellar guest. Even if the corresponding explanation has nothing to do with solar cells and extraterrestrial civilizations, at least some alien hope remains for the more alternative camp, because these are purely theoretical models and considerations that offer a plausible solution, but have not been directly proven in Oumuamua. Regardless, it is evident that no researcher has ever observed a comet without a dust coma, and that it is accelerating in such an odd manner as Oumuamua. However, it is also evident that Daryl Seligman and Jennifer Bergner have managed to reconcile the peculiar circumstances with a coherent theory. According to the experts, the answer to the Oumuamua question is hydrogen propulsion. In any case, the two arrived at this conclusion after reviewing a number of laboratory experiments carried out between the 1970s and 1990s. These tests demonstrated that water ice can break down into molecular hydrogen when exposed to intense cosmic radiation, and that an object traveling through the interstellar medium is literally cooked by that same radiation. Based on these findings, it would seem plausible that Oumuamua also formed hydrogen. However, the fact that the hydrogen should not have escaped into space immediately in order to explain the speed boost after Oumuamua's orbit around the Sun poses a problem. Fortunately, Seligman and Bergner had a suitable solution for this too. The hydrogen initially remained trapped in the pores of the ice. The theoretical calculations showed that this is anything but improbable. Most of the hydrogen formed in the ice under interstellar conditions remains trapped in the water. Matrix, this only changes when the icy prison warms up to temperatures between 258 and 133 degrees C, but as long as this temperature limit is not exceeded, the water ice remains amorphous. It only crystallizes when it warms up to the appropriate temperature. And while Oumuamua was entering our home system, the theory goes the sun's rays heated up its outer crust, causing the water ice to change its structure. The pores that were opened in the ice during this process allowed the highly volatile hydrogen gas to escape. This also explains why the outgassing appeared invisible to the terrestrial scientists. From a strictly visual perspective, the flying object apparently lacked a distinctive tail and a comma, unlike the typical comet outgassing, as the molecular hydrogen could not be recognized by spectroscopic examinations at all. All of this sounds good, but is this particular type of outgassing also appropriate for explaining the Oumuamua unexpected speed boost? The escape of hydrogen would also not result in any significant dust formation, and even if the ice matrix had contained dust, it was probably not carried away by the outgassing. Yes, it does, as long as the object is relatively compact. For example, if the comet were several kilometers in size, outgassing would probably not have a significant impact on flight behavior. However, if the cigar-shaped object was only 100 meters long and 20 meters thick, the process might have produced enough thrust to start the observed acceleration, and you could now produce enough thrust to start your click on the subscribe button. Join our community to ensure you never miss another one of our videos. See you shortly.